I'm looking at how the wind moves sediment across the beach. The wind will move sediment from the beach to the dune area, and then this will in turn promote the growth of dunes. There's a lake on the sand engine which is separated from wave processes. As the wind moves across the lake, it deposits its sediment in the lake, and once the sediment enters the lake, it then can't leave again. And this has resulted in the lake infilling. And what's interesting is that despite all of the variability in the different parameters that influence sediment transport by the wind, the infilling rate has been relatively constant across different years.
I've been measuring sand transport over time. I've also been mapping our dunes with a drone. I've been taking aerial photographs that I can use to really estimate changes in dune development and also changes in vegetation development. And linking these changes to transport processes really gives me insight into the dynamics that are at play. A key result is that the sand motor is supplying a steady amount of fresh sand to the dunes every year. Because the sand motor really acts as a buffer against dune erosion by storms, they're steadily growing towards the coastline. At the moment, a whole new dune ridge is forming at the sand motor. It's growing at a rate about 50 to 60 centimeters in height. And this is optimal rate for the vegetation to thrive under.
At the sand motor, I looked at the vegetation development, because that vegetation development is very important for dunes to develop, because the vegetation can actually stop the wind and catch the sand and thereby create dunes. And therefore I'm interested in what are the factors that limit that vegetation development. On the sand motor there's hardly any storm erosion, and therefore the plants survive the winter better, and which resulted to higher plant growth. So a higher plant growth leads to an increase in dune development. This increased dune development leads to higher coastal protection.